Hello. This is the video for the simple events page of the experimental probability assignment. If you're fourth period, this will be an assignment on its own. If you're in any other period, this is 1/2 of the experimental probability assignment. I will be uploading, might take me a second to get the other part up. I need to find a blank copy of this assignment. I may have exhausted those today, but I'm going to get it out to you for sure so you can complete it and hand it in. So, a simple event. When there is only one outcome for an event, it is called a simple event. So, to find experimental probability, you simply divide. Some examples of this are like rolling a single die, flipping a coin, drawing a single card, right? It's one outcome, and it's heads or tails, 8 of spades, maybe it's a 3 on the die, only one outcome. And experimental probability is found by dividing the number of times the event occurs you take this and you divide by the total number I'm going to write trials. If you're not familiar with that word, we've talked about it a little bit already. I'm going to say or attempts, right? So we'll use either the word trials or attempts. They mean the same thing. Now, for example, if Jose Altuve of the Houston Astros has a batting average of 0.311. That means that if he were to go up to bat 1,000 times, he would hit 311 times. You don't have to write this. It's only an example that I'm giving. So you don't have to write this. Just write this part here, okay? But I'm showing you an example of experimental probability. We don't know how well he's going to bat until he goes up to bat. Think of that as an experiment. It is an uncertain event where you can record what comes of it. So let's look at an example here. Shane has a bag of marbles and removed one marble and recorded it. He placed the marble back in the bag and repeated this several times. The chart shows the results. Find the probability of drawing each color marble. So here, if we think about Jose Altuve batting 1,000 times, we might consider how many times Shane pulled marbles out of the bag. To do that, we must add all of these together. So 10 plus 6 is 16, plus 20 is 36, plus 12 is 48. So 48 trials. Now, here, to find the experimental probability, you divide the frequency of the event by the number of trials. Okay? So, consider the red marble. Shane pulled the red marble 10 times out of the 48 trials. We can do 10 out of 48. Pick a number that divides both numbers. They're both even, so I'm going to pick 2. 10 divided by 2 is 5. 48 divided by 2 is 24. Here we have a fraction in its simplest form. Now for the blue marbles, it's the same equation. The frequency of the event, that means how often it happens or how many times it happened. the frequency of the event divided by the total number of trials. And the blue marble was drawn 6 times. So we can write 6 out of 48. Now to know 6 out of 48, you divide by the biggest number we can. We'll say 6, because 6 divided by 6 is 1, and 48 divided by 6 is 8. If you did not know it could be 6, you could try 2, and you get 3 out of 24, and those both divide by 3, and they'll become 1/8. If you divide by 2 and then you divide by 3, that's the same as dividing by 6. Now, we're going to keep doing this frequency of the event divided by the total number of trials. So we'll take 20 divided by 48, find a number that divides both. You may divide by 2 and get 10 over 24, divide by 2 again and get 5 over 12, or you could simply divide by 4. Instead of dividing by 2 twice, divide by 4. That'll get you to 20 divided by 4 is 5, 48 divided by 4 is 12. For the yellow marble, keep on going with that tried and true formula. Frequency over trials. The yellow marble was pulled 12 times, 12 out of 48. 48 does divide by 12, so you can just put a 12 there and there. 12 divided by 12 is 1. 48 divided by 12 is 4. And so this comes out to 1/4. Flipping over. The spinner has 4 unequal sections. Now, let's talk about this scenario. A spinner with 4 unequal sections. Now, your spinner may look like this. A, B, C, D. And here this is divided evenly. So we can say that each section has an equal likelihood of coming up on a spinner. That's 1 out of 4, right? Because there's 1 out of 4 equal portions. That's 1 out of 4. But not every spinner is going to look like this. It's already wonky looking. The sloppy circle. So maybe it's going to look something more like this. Maybe A is very tiny. Maybe B is a little bigger. Maybe C is about right there. And we could say D is right there. So this is less obvious because there's some really small parts and some really big parts. And we can't say it's 1/4 because some of these are definitely more likely than others. These are not all the same probability like in my other example, right? These are going to be all different. And the only way to know what it's going to land on more than any other, I mean, we can guess and say this will probably be the most common, these will probably be pretty similar, and this one will be the least. So you can make a prediction like that and test it out and see if we're right. But we have to do an experiment, and that's what experimental probability does. These have unequal sections. So for my unequal sections, what we have to do is we have to consider all of my spins. Now, Valerie spun 12 for purple, 17 for orange, 8 for green, and 14 for pink. If you add them up, we know that there were 51 total spins, 51 trials, 51 attempts, however you want to say it, 51. Now, we want to know about landing on the color orange. Color orange was landed on 17 times. So this is a trick for simplifying fractions. Write 17 here and 51 here. We're going to do factor trees. So you have 1 and 17. Now, we may not know what 51 divides by. But if I put 1 and 51, that won't be very helpful for what we want to do. So we're going to see if it divides by 17. Calculator is here to save the day. 51, no. Hold on. 51 divided by 17 is 3. So 51 is 3 times 17. So the goal is to get a matching number on each of your factor trees. When you get a matching number, you cross it out. Try to repeat it with your next number. If you can't, or if the only matching number is a 1, then that is your simplified fraction, 1/3. Because we have a 1 and a 3. Now, let's look at this next example. Jillian went bowling with her friends. She rolls a strike in 2 out of the 10 frames of bowling. What is the experimental probability that Jillian will roll a strike in the first frame of the next game? Now, this one's pretty easy. If you want to know what the fraction is, it kind of gives it to you in plain English. 2 out of 10. So let's see if we can simplify this. 2 and 10. Right, 1 and 2. Here this is 5 and 2. 2 is in both. And what's left is a 1 and a 5, or 1/5. Lastly, number 3. Zach and Robbie are competing to see who is the more accurate quarterback. What is the experimental probability that Zach will throw complete passes in the next football game? So we look here and we see what Zach did. So we want to know about Zach, which means we don't really care about Robbie's numbers. So we want to have the number of successful attempts. That's the number of complete passes, which we can see is 28, divided by the total number of attempts. Now that's not 28 over 42, because 42 is the number of times he missed, and that's the number of times he got it. And the total will be the sum of these two numbers. So 28 plus 42 equals 70. And we just simply have to simplify this fraction. So we try 28 and 70. We see they're both even. So I'll do 2, and 28 divided by 2 is 14. We do 70 divided by 2, you might use your calculator, and get 35. Just cancel. 14 and 35, do they divide by any common numbers? Well, that divides by 2 and 7. I know that much. 35 doesn't divide by 2, because it's odd, but it does divide by 7, and that's 7 times 5. So the 7s can cancel. 2 and 5 have no common dividers, so it's 2/5, which is my answer there. That is a pretty straightforward way I can show you to simplify fractions, which is usually your last step in considering probability. So this concludes experimental probability of simple events. I still need to upload the compound events. If my probability review video doesn't include the other side, don't sweat it, submit it as is. That was my mistake. We'll go over it a little bit later. So yeah, that video went on long enough as it was. So submit this. I'll have the video for compound events up a little later. Thank you for watching. You have a good day.